Hey everybody, Ethan here. Today I'm going to talk about CD8 positive cytotoxic T cells. When I learned about this, I actually thought about safeties in football. If you're not well acquainted with American football defenses, let me provide a small primer. Up front right here is the defensive line. If they can't tackle the quarterback or the running back if it's a run play, and the linebackers behind them can't contain the play either, and the cornerbacks on either side can't guard the receivers or stop the run if it's a run, then it falls to the safeties back here to clean up the mess. And in my eyes, those safeties clean up the mess and no one else can are like CD8 positive cytotoxic T cells. And growing up and to this day, I thought and think safeties are the coolest position in football because I just like the idea of when no one else can get the job done, these safeties have to get the job done. And that interest, that fascination is not actually based on me having played safety or whether or not I will ever play safety. The fact is I won't because I'm terrified of playing tackle football. You might think it's because I'm afraid of concussions, but the truth is I'm not actually afraid of concussions at all. The reason why is simple. If you think about a football field, you think about real football players, and then you put all 5'6" of me on that field with my arms like toothpicks and legs like chopsticks, I'm actually not worried about concussions at all. I'm really only worried about one thing. I'm worried about my impending death. My inability to play safety aside, I do want to talk about the safeties of the immune system, the CD8 positive cytotoxic T cell. Talk about three things today: development of the thymus from pro T cells, activation and proliferation of these cells, and lastly, their effector functions. First, let's talk about development. So starting with the pro T cell in the thymus, you need to be able to assemble the T cell receptor, seen here. These T cell receptors have two parts, the alpha and beta chain, unlike the immunoglobulin on B cells, seen on the left. You have to recombine or rearrange the beta chain first, and if that's successful, CD4 and CD8 are expressed. That's what the double positive comes from. You hear about double positive T cells because it's positive for CD4 and CD8. And once that beta chain rearranges successfully, then you rearrange the alpha chain. And if that's successful, boom, you have a functional T cell receptor on a double positive T cell. But one side note before we move forth, I said beta chain rearranges first, but in reality, there's a race between the beta chain and the sort of delta and gamma rearrangements. And if the delta and gamma sort of happens first, you actually create an entire different lineage of T cells. But the vast majority of the time, you do rearrange the beta chain successfully first, which sort of commits the T cell in this path, which then expresses CD4 and CD8. And then, of course, the sort of alpha chain gets rearranged too. I just want to mention that side note. I won't really talk about it much after this, though. So what do we now have? We have a functional T cell receptor that is double positive. And you think, okay, now we're in business, but we're really not. The reason why we're not is because T cells wield great power, and we don't want that power being used for nefarious purposes, right? We want T cells that can really attack foreign antigens that are expressed on self MHC. That's how the body expresses these foreign antigens, and we don't want the T cell to attack the self. And the way we sort of accomplish those multiple goals is by selection. So we're still in the thymus, right? Starting in the cortex, these double positive T cells interact with epithelial cells that express MHC class 1 and MHC class 2. Good recognition and binding of MHC class 1, right, seen here, causes the T cell to do a lot of things. First, T cell receives survival signals, so it keeps the T cell alive. And once it gets stayed alive, right, it's going to express more CD8 or continue for CD8 and stop expressing CD4. If the T cell receptor binds MHC class 2 really well, then okay, it's going to stay alive, get survival signals, but express CD4 and not express CD8. That's really the positive selection because we're selecting for, we're grabbing all the ones that can bind MHC. Well, and that makes sense, right? Because the body expresses these antigens. T cells really bind to MHC and MHC that presents with antigens inside. And if the T cell can't even bind MHC, then what's the point of even having the T cell at all, right? Because it's not going to be able to do the function that we set out for it to do. But there is also non-selection built into this first step too, because remember, binding to MHC well allows the T cell to receive survival signals. So if T cells can't even receive these survival signals, then they'll be non-selected for. They won't receive survival signals and they will not, survive. So that's sort of taking out the ones that don't bind MHC, like I said before, would not be useful. So now that we have ones that bind MHC, we move into the medulla and negative selection occurs. So now we have epithelial and dendritic cells that present MHC with self-peptide. What does that mean? It's literal peptides that are from the organism itself. This is not pathogenic or foreign material. It's MHC with self-peptide inside of it. And if these T cells and their receptors bind to MHC and self-peptide too tightly, then Sorry, see you later. These T cells receive apoptotic signals and pass away. And this sort of makes sense because what I said earlier, we don't want MHC that reacts to self. We want not MHC, we don't want T cells that react to self. We want T cells that can bind self MHC, sure, because that's how we express foreign antigen. But if a T cell reacts well with self MHC and self peptide, then that means that T cell could react to self cells that are not infected, right? And that's a bad thing. So this sort of this gauntlet of positive, non, and negative selection, ideally, and most of the time, hopefully, if there's no disease, gets you a prize CD8 positive T cell that binds MHC and self peptide, but not too tightly. This bad boy is going to leave the thymus, enter the lymph nodes and other secondary lymphoid tissues to get activated. And before we move on to that activation step, I do want to sort of provide this illustration because I think it really illustrates an important point. At every step we've talked about, we are losing a lot of T cells. So starting from naive T cells, beta chain range successfully, alpha chain range successfully, binding MHC class 1, but not too tightly. To get to our end product here as of an immature CD8 positive T cell, we lost a lot of cells in the process. Because again, a lot of this is just pure randomness, right? The random rearrangement, the random receptors being formed, and a lot of them aren't useful or actively harmful. And that's sort of how the selection comes into play. So hopefully we have one now that can be useful to us. And that use, it gets activated through activation and proliferation. What does that entail? It's at first, at a very, very basic level, it's simple, right? You have this immature CD8 positive T cell. It's going to meet up with an antigen presenting cell that's expressing a specific antigen on its MHC class 1, and they're going to bind really well, match made in heaven, and that's going to mature that CD8 positive T cell and allow it to have effector function. But unfortunately, it's not this simple. This binding here, antigen to receptor, antigen to TCR, is referred to as signal 1. It's necessary, but not really sufficient to trigger a true effector function response. There's actually 3 signals that we need to talk about. And again, yes, this is my high-level drawing. I apologize in advance for how bad it is, but I think it really gets a point across at least. Signal 1 is the key for one of the keys, right? You got T cell receptor to MHC1 with antigen, but it's really not sufficient. Signal 2 is also very important. You got CD28 on the T cell binding B7 on the antigen presenting cell. And this actually induces survival of the T cell. Similar before to how, binding MHC induces survival signals. Here, you want survival signals again to keep the T cell alive. Because you can bind antigen all you want, but if you don't get that survival signal, then that T cell won't live long enough to differentiate, activate, and move forth, right? So that's the signal 2. And signal 3 is also really important because this helps really make the decision. So once you have signal 1, signal 2, you're ready to go to work, but ready to go to work on what, right? Will the T cell turn into a memory T cell? Will the T cell tolerate the antigen? Or will the T cell, turn into an effector T cell that's going to go out, seek and destroy cells that present the antigen? The decision on what to do is really mainly based on that signal 3, the cytokines released, or the cytokine that the T cell takes up as it is being activated. So these are the 3 pieces, oversimplified, but hopefully the point is there. Another small note. In this picture, and I also said directly that these cytokines come from the antigen presenting cell, but that isn't always true. That assumes the antigen presenting cell is infected, but if it isn't, you actually need the involvement of CD4 positive helper T cells to actually secrete those necessary cytokines to really activate the CD8 positive T cell to really activate its effector functions. There are also more that I haven't even talked about. There's CD40, there's other stuff that's involved, but I'll leave it here for time's sake. This video is long enough. So just as a review, once you bind the T cell receptor to MHC with antigen, once you get signal 2 and you get inflammatory cytokines that provide signal 3, that says, all right, it's time to activate effector function. It's time to proliferate, divide a lot, and all those proliferated cells are going to have effector functions. So that begs the question then, what are the effector functions? Excuse me. There's a lot of them. But before I talk about them, I want to take a step back, right? Before I talk about this figure right in front of you, I want to talk about how we get here in bigger terms. We're so hyper-focused on T cell, we forget all the pieces that it took to get here, right? So what do? We developed, activated, and proliferated a cytotoxic T cell after it was found to bind very strongly to MHC and foreign antigen on a dendritic cell or an antigen-presenting cell. Remember this right here, right? It's important to realize where that antigen that we're talking about binding to came from, right? either the dendritic or antigen-presenting cell itself got infected, and that's presenting antigen from that virus or whatever on its own MHC, or it picked up antigen from the environment, right? Either way, this T cell is now on the hunt. It's been proliferated and differentiated and activated to be on the hunt for any self cell that's presenting that same antigen on self MHC. And this is in many ways, as I talked to earlier about being that safety, when everything else fails, the safety has to clean it up. This is a last resort for the immune system, because what this cytotoxic T cell, as the name implies, is going to do is be toxic to the cells. It's going to destroy both the infected cell itself and the virus inside. And that's not ideal. You don't want to really be destroying your self cells. But the reason why you do this is because it really doesn't have any other choice, right? Having to go to this means that, one, your innate immune function wasn't able enough to stop the virus. Neutralizing antibodies from B cells and the humoral response was enough to neutralize the virus. So the virus is not neutralized. It got into cells, it's infecting cells, and it's now utilizing host machinery to replicate. So that's not ideal. Obviously, that's where these sort of cytotoxic CD8 T cells come in. They need to destroy those infected cells. And that destruction, I mean, there's just a lot of options that the CD8 cytotoxic T cell has to go to work on these cells. A lot of options available for the cells. For one, you got perforins and granzymes, right? These T cells can secrete perforins that punch holes in cell membranes, which allow for the introduction of granzymes to enter these infected cells, triggering caspase cascades and apoptosis. Fast ligand on the surface of T cells can bind fast receptors on infected cells. That's sort of like the extracellular, I think, apoptotic pathway. And that also triggers caspase cascades and apoptosis. And also, finally, last but not least, the cytokine release from these cytotoxic T cells can activate macrophages to start phagocytosing stuff, and also increases MHC1 expression, which helps facilitate these other two, because better MHC1 expression means more potential ability for T cell receptors to bind and do all the stuff we just talked about. So for an illustration, at least of one of these things, perforins and granzymes, these T cell receptors, remember, they bind, they stick onto an infected cell, and that allows them to sort of exocytose perforin and granzymes in contact with the cell membrane of the infected cell. The perforin punches a hole in the membrane, allowing the granzymes through, and the granzymes, once inside the infected cell, go do their work and promote apoptosis via a caspase cascade. So that's sort of the beginning to end abbreviated of cytotoxic T cells. As a review, what do we talk about today? Development. Naive T cells must successfully rearrange their T cell receptors and bind MHC class 1, but not too tightly, where there's positive, negative, and non-selection in play. Once this happens, you got to activate these T cells. These immature CD8 positive T cells meet antigen-presenting cells with MHC1 and target antigen, and in an environment with signal 2 and signal 3, the effector function is activated and cells can proliferate. And what effector functions are we talking about? We're talking about perforins, we're talking about granzymes, we're talking about FAS, and we're talking about cytokine release. So a lot of stuff there. Again, this is an oversimplification, but I think it gets most of the major points across, right? I just think, again, this is the safety. This is when all else fails, you got to deal with infected cells. You turn to the CD8 positive cytotoxic T cells. So here are my sources. I hope this was helpful, informative. I wish you all the best. Take care. Have a good one. Bye.